Hello and welcome to the ICS 103 programming course in C. This is lecture number 9 where we're going to talk about functions. Okay, this is the first lecture on functions. Function is a very big topic, so we're going to be covering it in about 3 lectures. And here is an outline of what we're going to do. We're going to talk about functions, review them. We're going to have the type of function. We have the void functions, and we're going to talk about the actual arguments and the formal arguments, and we're going to talk about modularity and functions with input arguments, and we're going to cover all of these, their usability, logical function, and all the other information over here, such as the argument list correspondence, the function data area, testing and function using drivers. Then we're going to be taking advantages of using functions or sub-programs, as some people call them, for procedural abstraction and reuse of functions. So quite a heavy class this is, and let's start. Okay, so we basically introduced you in chapter 3 when we were talking about hash includes, and we told you to actually use the math.h and the stdio.h. You've been actually using functions from day 1. For example, printf is a function that you've been using from day 1. Scanf is a function that you've been using from day 1. We ask you to, are you using some mathematical function just as pow or the square root, we ask you to include the math.h. Okay, so you've been actually using functions and you are asking those functions to do the task for you. Okay, we learned about the steps involving defining our own user-defined functions. Okay, we have to declare the function prototype before the main function. We have to declare the detailed implementation after the main function. We have to call the function from the main function. Okay, so this is basically what you do. You declare a prototype before the main, you define the function after the main, and then you call the function from the main. Okay, however, we learned to write only simple types of functions, those functions that do not return anything and do not take any input. This is what we learned. In this lecture we're going to be going in more details, and we're going to be expanding on that, and we're going to show you how to write functions that can take input, produce an output, and all the other related information with it. Okay, so we usually use something that is called a function argument to communicate with a function. Okay, what are these? There are 2 types of argument. There's an input argument, there's an output argument. Okay, so think of it, when I tell you to multiply 2 numbers, what do you basically do? You wait and listen for the first number, and what you do inside your brain, you go allocate a memory and you say, okay, I'm going to put the first number over here, and I'm going to put the second number and the second memory that I actually allocate. Okay, and these are variables that you're defining inside your brain that will take the input. So when I tell you to multiply 5 by 2, you're going to take 5 and put in this first memory, and you're going to take 2, you're going to put in the second memory, and then these are your input arguments. Then you're going to multiply these 2 numbers. Okay, so you're going to use your brain, multiply 5 by 2, and the result is 10. You're going to be actually storing it somewhere else in your brain and then speaking out the result to me. So that is how you actually do calculations in your brain. Okay, so you have input, you use your senses to do the input. You might read them from exam, you find them written on a paper, so you read them using your eyes, or when I'm talking to you I can give the input using your ears. You can take the inputs, but all of them are going and translated inside your brain to variables that you're actually storing them into. Okay, so input arguments are arguments that you actually provide a function. You tell it, okay, these are arguments and these are for you an input, and I am as a user going to give you the input through these arguments, though I call them input arguments. Okay, ones that are used to pass information from the caller to the function. So from the outside world to the function, I use the input arguments to put the inputs inside the function so that it can actually go and start working on that. Okay, the output arguments are also arguments that we use to deliver the output. So okay, so when I tell you to multiply 5 by 2, if I'm talking to you, you're going to say it. So you're using an output function of the voice. If you are in an exam, you'll be writing it down on a piece of paper. So you're using the output as a something that you write on a piece of paper. Okay, so output arguments are arguments that you actually allocate so you can actually produce an output and give it to the function that calls you. Once that returns the results to the caller function, and we actually can use it to pass the value back to the function that called it. Okay, so we're now going to talk about the output arguments in this lecture. The next lecture we'll be talking about output arguments. In this lecture we'll be concentrating mostly on the input arguments. Okay, so let's talk about how we can actually declare functions. Okay, usually in any C program you'll have the hash include directives on the top, hash include, hash define, all the directives on the top. Then you will have the function prototypes on the top after the directives. Then you will have the main function, and after that function you will have the function definitions. Okay, this is a good structure of any C program. Okay, what does each one do? The function prototypes tells the compiler, hey Mr. Compiler, since the compiler of C goes line by line, it tells it, hey Mr. Compiler, I have functions and these are the names of the functions, so please, if you encounter them into the main, do not throw me an error. Okay, so here's how you define it. Just remember this, you'll have to define the prototype on the top, then the main function, and then the function definition in the bottom, and we're going to go in details on each one and how we're going to call them and how we're going to make them. Okay, so first of all, let's start with function prototype. Function prototype have three and only three objectives. Okay, it has to tell us what does the function return. If it returns something, what does it return? If it doesn't return anything, you have to tell me that it doesn't return anything. Okay, so an example over here is the word void. Void means it returns nothing. These are three examples of three functions. The first function is a void. So I'm telling the compiler, this is what I'm telling the compiler, hey Mr. Compiler, you have a function, but the return type is void, so it's not going to return anything for you. And then the next thing we have is the function's name, which is print underscore instructions. This is the function name in this example. And then a formal parameter list, and the formal parameter list is whatever written between the two brackets. In the first example, we have no formal parameter list, so I'm telling the compiler, hey Mr. Compiler, you have a function that takes no input and produces no output. Okay, and the function name is print instructions. Okay, so basically this function goes and prints something to the user and comes back. Okay, so we don't need any output and we don't need any input for it. Okay, so suppose you are making a program for a bank, let's suppose, and this is the welcome screen. So you say, welcome to software XYZ, copyright 2013, whatever extra details you want to. You might put the contact of your company or something, or you might put the logo of your company, or you can put all this stuff you want to print it out, and that's what you want to do in the beginning of the program. So as soon as you run the program, you call this function, and it takes no input. Of course, the program runs, you don't need to have any input, and it will produce no output because it's going to print the telephone number for the support, it's going to print the name of the company, it's going to print the logos, whatever it has to print to the user. Okay, another example over here is, this is int, and I'm telling the compiler over here, this is a prototype. So Mr. Compiler, you have a function, the return type of the function is an int, so it's an integer type return. So this function, when it finishes, it will return for you an integer type. Okay, and the name of the function is compute GCD, and GCD is for the greatest common divisor. So it's compute GCD, and between brackets I give it two input arguments or formal parameters, int x and int y. So I have to declare the type of the input parameters that the function is expecting. So it's expecting first input to be an integer, a second input to be an integer. Okay, and here's a third example where the output is a double. You can have output as a character, as a double, as integer, or any other type that you actually have learned till now. Okay, so in this example we're using a double, and the name of the function is cal underscore average, and it takes two inputs. One is called double total, and int n as the second input. So it takes a double and an integer. So you can actually have any type of inputs. You can have a double, integer, character. You can have multiple integer variables, integer, 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 integer. You can have as many input variables as you like, and you can have as many types as you like. Okay, so you're not actually bound by a single type. So it doesn't mean the first one has to be a double, the second one has to be an int. It can be any type. It could be int double, it could be double int, it could be double 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 int, it could be int double int, whatever character, whatever input that you want to give to the function. Okay, so usually anything that is written between these two brackets are inputs for the function. Okay, so you have to declare the prototype the first thing in your program. So these prototypes have to go where this line is written in this, actually this line is written in this structure. So you define the function prototypes after the hash include. Okay, So this is the prototype, talking about the prototype. When you want to call the function from the main, and suppose you want to call int compute GCD, and this is the prototype, int compute GCD, int x, int y, and you want to call this from the main program, this is the line that you will write, and you say you don't declare the return type in the main. Okay, so whenever you're calling a function, you just write the name of the function. If it returns something, make sure that you save it somewhere so you can access it in the future. Otherwise, you can, if it's a void type of function, you can actually just call it directly. Okay, so if it returns something, save the result so that you can use the result in the future. And you say result is equal to compute GCD, so you put the function name, and in between brackets you put the values that you want to pass to it. Okay, so if you put 12 and 38, you're actually passing 12 to the first input and 38 to the second input, so that it calculates the GCD for you for these two numbers, the greatest common divisor. Okay, or you can actually declare variables, okay, like a and b, and then you scanf the variables from the user, so the user enters two numbers for you, and then you can actually call result compute GCD a and b, and between brackets you put a and b, the variables that you want to pass. So you can actually pass constant or you can pass variables. Okay, both of them are allowable. If you pass constant, you pass as constant value, so your program will become static. You cannot change it. But if you pass variables and you read it from the user, then your program becomes dynamic and interactive, and you can actually take the inputs and you can actually pass different inputs using compute the GCD. Okay, these are called the actual parameters. This is what you're actually passing over here. What are we actually passing? Number 12. What we're actually passing is number 38. What are we passing over here? We're passing the value that's stored in A, which was entered by the user, and over here we're passing the value that was entered by B, which was entered by the user. Okay, these are called the actual parameters, whereas these are called the formal parameters, where they are the parameters that the function uses when it's working inside of its own memory. Okay, and I'll come to that in a second. Okay, then comes the function definition. So suppose I have this as my prototype, int compute GCD, int x, and int y. I have to go and write the same thing over here when I'm declaring the function. Okay, so when I'm writing the function, I put the same thing as the prototype, but instead of a semicolon, I put curly bracket and close curly bracket. So I tell it that this function, these are the steps that it does. Okay, so whatever you write between these two curly bracket, these are the steps that the function is going to go and perform whenever this function is called. Okay, so it might have declaration of some variables, some calculations, and then at the end you will have the return statement. The return is a keyword, and some value over here you're going to return, and make sure that you return an integer number. Okay, and we're going to have an example where we're going to talk in details about this, but this is just to give you an overview that when you have a prototype, with the prototype you have to have an implementation of the function, and this is a complete implementation. A prototype always ends with a semicolon, and the implementation has the two curly brackets to tell you what the function basically does. Okay, so we know how to write a prototype, we know how to call a function from the main or from any other function for that matter, and we know how to implement a function. Okay, let's talk about types of function. There are functions that have no input argument and no value returned. Okay, these are void functions without arguments. We call them void functions without argument. An example is just like the example I gave you in the beginning. If you want to print something on the screen, as soon as you run your program, you want to print, for example, you want to print your name. Okay, so you say this program is written by Akram Ahmed. So I'm going to go and make a function called print. It will be a type of void. It's not going to return anything. It's not going to take any input. And when I run my program in the main thing, the first thing I'm going to do, I'm going to call my function, and that function is going to go and print this program is written by Akram Ahmed, and that's all it does. Okay, so this is a function that has no inputs and returns no value because it's basically doing some printing. Okay, there are functions that have input arguments, have no return values. Okay, so a function that you can actually give input to and it doesn't return anything. An example, the printf function. Okay, the printf function, you've been using it, you actually give it values and it goes and prints it on the screen, but it returns no value to the program. Okay, so the program, when calling the printf function, is not expecting anything from the print function back. Okay, so the printf function takes an argument and then prints onto the screen. We do not need to assign the result of the print function to any value. Okay, it always prints it on the screen, and the user can see it and then interact with it. So this is an example of an input argument with no return values. Okay, so we have input arguments, so we give it variables, we give it text, we give it things to do, to print on the screen for the printf, and then it returns nothing. There are functions that have input arguments and a single value returned. Okay, so it returns a single value. Okay, an example of it, this is the square root function, the sine function, the power function, or any function basically in math.h. Usually all of them is like the power. You give it multiple inputs and you expect from it to give you one output. So if you want to take, let's suppose 2 to the power of 4, you want to give 2 and you want to give 4 to the function, and you give it to it, and then you expect from it to return for you one number, a single number, an input, a single output, and multiple inputs. So you have input arguments and a single value returned. That's another type of function. The final type of function is input arguments with multiple values returned. We are not going to talk about this in this lecture. We're going to talk about it in the next lecture. So you can actually have multiple inputs, multiple outputs, but we're not going to talk about it in this lecture. Okay? And this example for this is if you wanted a single function to calculate the circumference of a circle and the area and return back to you. For some reason you might want to write that function, and in that case you will have multiple outputs and multiple inputs. Okay? So let's talk about each function one by one. So void function with input arguments. A function that takes one or more argument as an input but returns no results. Okay, this is an example of it. Void print are boxed. Okay, such functions should be declared as void functions because they don't return. When you don't have any return value, declare the function as a void type. So in the prototype you'll have void, the function name, and then the arguments between brackets. But each argument should be declared in brackets following the function name. An argument is declared in the same way as a variable. So when you want to declare an argument, you have to do it in the same way. You have the variable type, then the variable name. Okay, so an example is here. This is a void function, and the name is print r boxed. And in between bracket, it takes a single input as a double and names it r num. Okay, so r num is our variable. It's a type of double. It's an input argument that I'm going to give the function print r boxed, and it's not going to return any value. Okay, so the r box function, print r box function, is going to take a value and write it and print it in a box. Okay, and we have an implementation for it in the coming few slides, and I'm going to show it to you in a few seconds. Okay, if there are more than one arguments, they should be separated by commas. So if you have one argument, that's it, you put it between brackets, you put the type, and you put the name of the argument. If you have more than one argument, in between the brackets you put the type, the name of the argument, comma, the type, the name of the second argument. If you have more than this, then you have the name, the type, name, comma, type, name, comma, type, name, comma, type, name, comma, and you can go on as long as you like. Okay, so this is an example of when do we have a function that has a void output or no output, but it takes an input, a single input. Okay, so here is a function that is actually working to print r in a box. So we give it a value, and it's gonna go take that value from the user and print it in a box. So the output we would like to have is, we'd like to have the value, we ask the user enter a double value, so he's going to enter for me a number, whatever number he chooses. In this example is 135.68. What we want to do is we want to print the 135 in a starred box. Okay, so this is a box and we want to print the number inside it. Okay, so this is the aim of our program. So in this program, we start with our directive and we include stdio.h because we're going to be using all the commands that are in the stdio.h. Then we declare our prototype. So we have a function called rbox, which is going to go and take the value for us and print it inside a box. So this is a void print rbox double r and num. Okay, so we're telling the compiler, hey Mr. Compiler, I have a function that returns nothing. The name is this, and it takes a single input, and then I end it with a semicolon. Then I go to the main function and I start doing my main function. In my main function, I define a double variable x, and then we actually ask the user to enter a number, and then we read it and we store it into x. Okay, so we read a scanf, %lf, and the address of x. Then we call the function print rbox and x. Okay, so notice over here we did not put any void over here. Okay, so return type is not specified when we call a function, and we passed it the value of the variable x, which was entered by the user. So we took the input from the user and we passed it to the function print our boxed. Okay, so the function from here is going to jump and go and do the implementation and then come back and continue. So the program is going to run from the main line by line. When I have a function call, it's going to jump to the function, do the function, finish it off, come back and continue my program. Okay, so print our box, and I'm going to have a value x, so it's going to jump over here and it's going to store the value of x into our num. Okay, so the value of x is going to be copied into the our num, and then it's going to go over here and start executing what you have written. So it's going to printf, and you're going to print the stars line over here. So you'll have the lines, the first line of the stars. Then you have printf, you have a hollow line over here, star and star. So it's going to print the star and star. And then you have printf, and you have star and percentage 7.2f, and then a star slash n. So it's going to print star, and then it will allocate space, and then 7 spaces where it's going to print for you the number that was entered by the user, and then a space, then a star. Then you have the stars printed and the line printed, so it's going to print this. So when you call our box, this is what's going to do. It's going to print the first line, then the second line. It's going to print a solid line, then a hollow line, then the number and a hollow line, then a hollow line, then a solid line. And this is basically what the program is doing. When it finishes over here, it's a void type, so you don't have to have the return statement. You come back over here, you have return 0, and your program stops. Okay, so you see how we actually use the function over here. We called it to actually print a number in a box. Okay, and that's why we have an our box number. We give it a value, we gave it x. X will be stored in num. Now here's what goes on into the memory of a computer and how the program actually runs. When you start the memory, when you start the main program, you are allocated a memory for the main. Okay, when you declare a variable x, it's gonna go declare a variable x in the main and allocate a space for it where the value of the variable can be stored. When you come, you ask the user to enter the value of x, so you print this, it's going to be printed on the screen. You're going to ask the scanf to actually take an input from a user. So the user is going to input a number, it's going to be written over here. So suppose the user enters 135.68, it's going to be stored into x because x is a double number. Then when you call print our box, what do? Is you are actually going and instantiating a function call. Okay, so this is a function call. When you call a function, you will go and allocate a new memory for this function, and you will name it print underscore our boxed. Okay, and in that you're going to declare a variable, whatever is declared into the function header. So this is the function header, this is the implementation. Whatever is declared between as an input argument, declared between the two brackets, you're going to go and declare it. So you're going to declare our num into the print box memory, and then you're going to pass it the value that the function, the calling function, is passing it. What is it passing it? It's passing it the value of x. What is the value of x? 135.68. I'm going to pass it to the our num, so our num is going to have 135.68. Okay, so I passed it a value, and this is called pass by value. Okay, so you copy the value of x into the copy of our num. Okay, so you copy the value from here to here. You copy the value of x into the our num. 135.68 becomes 135.68. Okay, this is pass by value. So you actually are going and passing it over here, and then it's going to jump over here and execute this. Now when it runs this program, it only has access to this memory. It doesn't have access to this memory. Okay, it only has access to this memory because you can only access variables that are inside the function. Okay, so over here, if I tell you what is the value of x, you will tell me I don't know. Okay, I don't know what x is, because x is declared into the main. It is in the context of the main. It's not in the context of print our box. So inside print our box, x doesn't exist. Only our num exists in the context of print our box. In the main, only x exists and our num is not there. Okay, so it doesn't exist. So that is why we copy the value from x to our num, so that this function will have the input. So suppose this is me, I have the number. I'm telling the function print our box, take this number and do something for me, print it with a box on it. So the function is going to take the rnum and it's going to print this, and then it's going to print, notice over here, it's going to print rnum because it can only access rnum since I am in the space of the function print rbox. Then it's going to print this, and when I finish this, it's going to actually delete this for me and come back into my main program. Now I come back to X, and then I have return 0, so I actually delete the main and my program ends. Okay, so this is actually what's happening in the memory of the computer, and you can see the sequence of the program and how the values are passed by value. Okay, now going further, the actual arguments and the formal arguments. What is an actual argument? Is an expression used inside the parentheses for a function call. Okay, so whatever is inside the parentheses of a function call, like the double rnum in our case, this is called the actual argument. Sorry, the formal arguments. Okay, so the actual arguments, expression used inside the parentheses of a function call. Sorry, the actual arguments are what is inside the main. So if we go over here, the actual argument is x, and the formal argument is rnum. The actual argument is x, and it next takes the value that the user entered, and we're going to pass it to the formal argument rnum, which is in the second memory, and we're going to give it so that the second function can actually, or the print rbox function can actually work on it. Okay, so the formal argument, an identifier that represents a corresponding actual argument in a function definition. Okay, so it is a correspondence. So when I did this example, rnum is a correspondence of x, so has the value the same as x, but we are going to call it rnum in this second function, and the first function we're going to call it x, and the main function we call it x, and the second function we call it rnum, but they are correspondent. We pass the value of x to the rnum so that the function can have the value. Okay, actual arguments can be an expression, evaluated to a value expected by the function, so you can have it a variable, you can have it a constant, or you can have an expression. So it will evaluate the expression, and then the result of the expression is going to be sent to the function. Okay, when the function call is encountered at runtime, the expression of the for the actual argument is first evaluated, then the result value is assigned to the formal parameters of the called function. Okay, so if you have something like x plus y in the function call, so if we come over here back in our case, and in this example we say rbox x plus 5, you're going to evaluate x plus 5 first, and then pass the value of x plus 5 to rnum. Okay, arguments make functions more versatile because they enable a function to manipulate different data each time it's called. Okay, so you can actually manipulate different types of data, and you can work with large numbers every time you call them. Okay, writing modular programming. How do you write modular programming? Suppose we wish to write a program that draws a rectangle similar to the following given in length and width. So you want to draw a rectangle, and I want to draw it while I'm giving a length and a width. Okay, so how would we actually do that? How would we draw a rectangle? Okay, it's pretty simple. We draw a solid line, so this is a solid line, and in the solid line we have to take a character and we have to print it. We have to print it how many times? We have to print it how much is the length. We have to print that character at the same time. Okay, then we have to draw hollow lines. How many hollow lines do I have to draw? These are hollow lines, the strikes, and has nothing in it, spaces, empty spaces. We have to draw a hollow line. How many hollow lines? We have to have the width minus 2 hollow lines, because the first and the last one are solid lines. So after we draw the hollow lines, we have to draw a solid line, and this is how we draw a rectangle. Okay, it is possible to write a very long main method to implement the above algorithm. However, this will involve many repetition, and you'll have to have many for loops, and your code is not going to look very nice. Okay, a better approach is to implement a different component of the solution as a function. This will result in a modular program. Okay, and in this we will define 3 functions. One is draw a rectangle, and the draw rectangle has the responsibility to draw a complete rectangle. We have a function called draw solid line, and it will only draw a solid line for me. Whenever I call this function, it's going to draw a solid line for me. What it's going to do is going to print the same character again and again, the number of times the width specifies. And then we'll have a draw hollow line, and this draw hollow line is a function that will draw a star, and then space, empty space, then a star, and the total number of characters should be the width. So we'll have 2 stars, and then we'll have the width minus 2 spaces that has to be so that we can draw a hollow line. Okay, so here is the code of the draw rectangle function. So we have our directives, the hash include to the dash. Then we have the 3 function prototypes. Notice we end them with semicolons. We say void because this is something that's drawing for the user. It's not going to return anything. Draw solid line, and you give it an integer size. And then you have draw hollow line, integer size. Then you have void draw rectangle, integer length and width. Okay, so for draw rectangle, you need the length and the width. But for draw solid line, the hollow line, you have to only give it the size of the line that you are actually printing. Okay, so let's start our program. This is our main, and when we start our main, we will have integer length and width. Okay, to better explain this, I'm going to draw a memory map on this paper. Okay, so I have a different sheet of paper where I'm going to draw the memory map, and I'll be moving it around as I go on into the program. Okay, so when I start my main, I will have a memory allocated for me in the main function. Okay, when I have memory allocated for me in the main function, I go have integer length and integer width. I'm going to allocate a memory for length. Okay, so length is going to go save a memory for me, and the size of it will be 4 bytes because it's an integer. And then width, I'm going to allocate another memory and call it width, and that's going to allocate for me another space for width where I can store the value. Okay, then I ask the user to enter the length and width, and the user is going to take enter 2 numbers for me. So for example, over here I am going to be taking the user entered for me 4 and 3. So whenever the user enters 4 and 3, I'm going to save the address of length and the address of width. So the address of length and the address of width is 4 and 3. Okay, now we have a function called draw rectangle, and it will take the length and the width. When I call the function draw rectangle, I have to go to the function draw rectangle. Where is the function called draw rectangle? This is the function called draw rectangle. In the function draw rectangle, notice, I'm going to move this a bit up. Sorry about that. In the function draw rectangle, I have to allocate a new set of memory. Okay, so I say draw rectangle, and I allocate another set of memory, and in it I have to say len, integer, and wide as integer. Okay, so I have 2 variables that I have declared over here, and I'm going to declare them into my memory because these are the values that are declared in my function header. Okay, and what am I going to do over here? I'm going to copy in them the values that are passed by the main function. So the main function is calling draw rectangle and giving me the value of length. It will be copied to len, and the value of width will be copied to wide. Okay, so the first one will go to the first one, the second one will go to the second one. So the value of length, what is the value is 4, is going to copy to len. So I'm going to have 4 in len and 3 in wide. Okay, clear? And then going on, we will continue with our draw rectangle. And over here I have an I, so I'm going to declare an I as a variable. And then I go and call a function called draw solid line. When I call a function called draw solid line, I am going to have another memory allocated for me, draw solid line. Okay, and this memory is going to be allocated for me, and I'm going to go to the draw solid line. This is the draw solid line, and I'm going to come over here and say I have a size as a variable declared for me, and it's a type of integer. Okay, so what is the value that the size is going to take? Is the value that's passed to it is the value of len. So I'm going to take whatever the value of len and put it over here, and then so I'm going to have 4. Okay, and then I continue the draw solid line in a sequential manner, and I have I as an integer, so I actually declare an I, and then I say for I equals to 1, so I will become 1. Is I less than or equal to the size, so I less than or equal to 4, I plus plus, then I print a star. So at the output, what I'm going to do, I'm going to print a star, and then increment I by 1, check if it's less than the size. So I2 is going to be less than 4, and then I'm going to draw another star, and then I'm going to go increment I. So I'm going over here, drawing a star, coming I is equal to 2, drawing a star, I is equal to 3, drawing a star, I is equal to 4. It is true, I draw a star, so I draw 4 strikes out. Okay, so just to illustrate that, I'm going to do my output. So suppose that this is my screen, so I'm going to go put 1, 2, 3, 4 strikes on my screen, and then printf, so my cursor is going to come to the next line. Okay, and then I finished my draw solid line function. Okay, so when I finish my draw solid line function, this information is going to delete. So this is going to be 1, 2, 3, 4, and then 5, and it's going to delete as the counter goes up. The numbers are going to go up. Okay, then when I finish this function, I have to go back to the function which called it. Which function called it? The draw rectangle function. And I was here, I did this function, I go and continue, and I say if length is greater than 2. Is length greater than 2? So len is 4, yes, len is greater than 2. I am going to go over here and start for I equals to 1, so my I is going to take the value of 1. Is I less than wide? Wide is 3. Yes, this is wide minus 2. 3 minus 2 is 1. Is it less than or equal? Yes, so I'm going to go and draw a hollow line. When I go to draw a hollow line, I am going to be allocated a new memory called draw hollow line. Okay, and inside it I'll have size. Okay, I have a variable size because it's actually declared inside the parameters of my function. So it's an input parameter, and I'm going to put into it the value that's passed to it. What is the value that's passed to it? In the draw hollow line, I am passing it len. What is len? Len is 4. So I'll pass len 4. The value of 4 will be actually copied to the, will be copied from here to here. So if this 4 len is going to be copied over here. Then I come to the draw solid line. I have an integer I, so I have an I. And I'm going to go ahead and print a strike. So I'm going to go to the screen and print a strike. Then say if size is greater than 2. Is size greater than 2? Yes, 4 is greater than 2. So I'm going to say for I equals to 1. So I have I equal to 1. Is I less than the size minus 2? Yes, that's true. I'm going to print a space. So I'm going to print a space over here. And I'm going to indicate a space by a empty line. So my cursor is going to move forward. Then I'm going to go and increment my I by 1. So I will become 2. So this I will become 2. Now when I becomes 2, I'm going to go and check this condition. Is I less than size minus 2? Size is 4. Size minus 2 is 2. Is 2 less than or equal to 2? Yes, that's true. So I'm going to go and print another hollow line. So I'm going to print another hollow line over here. Then I'm going to increment my I by 1, and this condition then becomes false. I'm going to come over here. I have to print star, then /n, so my cursor is going to go down. Then I'm going to come back over here. I'm going to finish this, so I'm going to delete this memory. I'm going to come back over here, and when I come back over here, I'm going to increment I by 1. So I was 1, now it will become 2. Is 2 less than or equal to wide minus 2? Wide is 3. 3 minus 2 is 1. Is 2 less than or equal to wide? No, it's not true. So I'm going to jump out of the 4, and I'm going to go to a draw solid line. When I go to a draw solid line, I'm going to be allocated a new memory called draw solid line. And in the draw solid line, what's going to occur is I'm going to go to the draw solid line, and I'm going to go and name something called size. Okay, now this size is different from this size, is different from this size. These are three variables that are in different domains, so they don't know that each other exist, and actually we have actually deleted those two. Okay, so this is just like having names. You can have many people named Muhammad, you can have many people named John, many people named Khalid. Okay, but all of them are different. So now what am I going to pass this? I'm going to pass it len. Over here I have len. What is len? Len is 4, so I'm going to go to the size and pass it the value of len. So I'll have 4 inside over here. So after I have 4 inside over here, I have to go to draw solid line, and I have to conduct this. So I have declare I. So I declare my I over here, and I is equal to 1 in the first case. For I equals to 1. Is I less than the size? I less than 4. Yes, I go ahead and print a star. Then I come back, increment I by 1, so I becomes 2. Is 2 less than size? Yes, so I go ahead again and print a star. So I increment I by 1 again, so it becomes 3, and then I go and print a star. Then I increment my I by 1, becomes 4, and I go ahead, this condition is true, so I print another star. And then I increment I by 1, becomes 5. Is 5 less than 4, which is size? No, it's not less than size, so I jump out and slash n, I actually go to the new line. When I finish over here, I come back over here, and then I actually finish my program. Okay, so when I finish this, this is going to be deleted. When I come back over here, draw rectangle is going to be finished, so I'm going to delete this memory. Then I have to return back to my main, and I have system pause and return 0, so my main will be deleted. Okay, and to see how the memory extension occurred and how I went from one memory to another to actually do my work. Okay, so at the end you will have a box printed for you as a draw rectangle. Okay, now moving on, functions with input arguments. By far in C, this is the most used functions. Okay, these are functions that have multiple inputs and return for you a single output. All the functions that are in math.h are basically functions that are of this type. Okay, just like the square root, the log, the abs, sine, cosine, and all the other functions are functions like this. These are functions that take multiple inputs and return for you single output. Okay, unlike void functions, for which the function's call is statement of its own, functions that return a single are often called part of another expression. So when there are functions that return something, it is not a statement, it is an expression. Okay, so it's basically returning something for you, so you have to save it somewhere so you can use it, or you can actually use it inside a mathematical equation. So it actually goes to the function, calculates a value, returns, and plugs it into the mathematical equation, and then calculates the result for you. Okay, so for example, draw rectangle, when you call the function, you call it draw rectangle and you give it 2 numbers to actually draw a rectangle. If you're calling a square root function, you can actually say root 1 is equal to an equation, and you call a function and you put your function inside a mathematical expression. So this function is going to take 1 value or 2 value and return something for you, and then use it to evaluate the expression and store it into a variable. Okay, in the function declaration and the prototype, the function draw rectangle, as we've seen before, is a type void, whereas in this type, when you return something, you have to specify the type that you return. So you have to say double, integer, character, whatever return value that you want. Okay, now we have function with input arguments and single results. So functions that return a single result must have at least one return statement. Okay, so any function that returns a value has to have at least one return statement, and as soon as you hit the return statement, your function is going to stop. You're going to go back to the function that called you. Okay, don't continue after the return. Once you hit the return, that's it, go back to the function that called you. Okay, now here's an example, the function that computes a factorial. What's a factorial? A factorial is, if you have 5 factorial, the result is 5 multiplied by 4 multiplied by 3 multiplied by 2 multiplied by 1 multiplied by 1. Okay, so that's basically a factorial. So 5 n factorial is n multiplied by n minus 1 multiplied by n minus 2 multiplied by going on until 2 until 1. Okay, so to do that, we have a function and we call it an int function. It returns an integer for us. Okay, and the name of the function is factorial. Okay, so we call it factorial, and between brackets we give it a number. Okay, so usually factorials are functions that take a single number and return a single output. Okay, so factorial n, so you give it the number which we want to calculate the factorial with, and usually factorials only defined for integer number, it's not defined for double numbers. So int n, this is the input argument that you have, and it's going to return a factorial for you, and inside it you actually declare I. This is a local variable. Okay, so what's going to happen over here is you're going to be having a memory for the factorial, and inside it you'll have n as a variable. This is a variable input parameter that you're going to give it, and you have a local variable called I and a local variable called product, and you put it equal to 1. Okay, So you declared two local variables. Okay, local variables are variables that are declared inside a function and nobody knows that they exist, only the function knows that they are there. Okay, because it's inside the scope of this function, it's not inside the scope of any other function. So you declared I and you declared product and you assign product to be 1. Now why did we assign the product a value of 1? Product is the variable where we're going to be saving all the multiplication of the numbers. Okay, so we have to initialize it by the identity of the operation that we are using. We are using multiplication, the identity of the operation is 1, that is why we initiated it by 1. Okay, now we want to compute the product x n multiplied by n minus 1 multiplied by n minus 2 going on. So we say for I equals to n, I less than 1, I minus minus or minus minus I, product multiply equals to I. So I'm actually going I from n, and the value of n is actually passed to me. So the function who calls me is going to set the value, whatever its value is going to set, I'm going to start with it, and then I'm going to decrement I by 1 each time until I'm greater than 1, and I'm going to be taking the value of I, multiplying it into the product. So I'm going to start with 5, then multiply it if n was 5. So suppose n was 5, so I'm going to take 5, so I starts from 5, and then I'm going to go and say product is equal to product multiplied by I. So what is the product? 1 multiplied by I is 5, so it's going to become product is going to become 5, and then I'm going to go and decrement this by 1, it's going to become 4. So I'm going to multiply 5 by 4, that's going to be 20. Then I'm going to go and decrement, this is going to become 3. 3 multiplied by 20 is 60, and then I'm going to decrement I, 3 is going to become 2, I is going to become 2. I'm going to multiply this, is going to be 120. So all of these values are gone now, and then I'm going to come, and this condition is not going to be true because I is now 1, so I'm going to jump out. So I will have inside my product 120. Okay, so this is the factorial of 5. Okay, so the real code for this is the factorial function, and you can actually implement this into a real function, and you have your hash directives, you have to have the prototype. So this is the prototype. You say int factorial int n, and then semicolon, the input parameter is n, and the output it returns an integer, and you end it with semicolon. In the main function you define a num and a factorial. You ask the user to enter a number and you save it in num, and you say if num is less than 0 you cannot have a factorial for a negative number, and you print it to the user. Otherwise, if it's less than 7, you can say factorial is equal to factorial and num, and over here you're going to pass the value of num to the factorial n. Okay, so you take the value whatever is in num and you go to n and you actually pass the value of num to n, and then over here you calculate the factorial and you return the product. So when you return the product is going to come and be stored into the fact. Okay, and then you're going to print this factorial. Else you say the number is too large, and if you are working on a very small processor or you didn't have memory to do that, you will actually say that this number is too large. You have to use another method to actually calculate the factorial of a number that is greater than 7. Okay, system pause and return 0. So the program is going to run over here, take the num, pass the num to n over here in the factorial, calculate the factorial, come back, put the result into fact, and then it's going to print the number and the fact, which is the factorial, and then you're going to stop your program. Okay, so this is the factorial in a very short description. Now, why do we have functions? Okay, we have functions because we want to illustrate reusability of function. Okay, so if we need to write another program that uses the same function, we do not need to rewrite the function. Just we have to change the main function and then call the function as many times as you like. Okay, for example, suppose we wish to write a program that computes how many different ways we can choose our items from a total of n items. Okay, so how many ways you can choose 2 letters from 3 letters. Okay, so you have 3 letters A, B, C. How many combinations you can have? You can have AA, you can have AB, you can have AC, you can have BA, BB, BC, you can have CA, CB, CC. Okay, so to do this, from the probability theory, we all know that the number is given by a combination formula. So choose n and r. It's n factorial divided by r factorial multiplied by n minus r factorial. Okay, so in our example, if we have 3, so we have 3 and 2, you have 3 factorial divided by 2 factorial multiplied by 3 minus 2 factorial, which is 3 factorial divided by 2 factorial multiplied by 1 factorial. 1 factorial is 1, 2 factorial is 2, 3 factorial is 6. So you divide, there are three ways. Okay, so to do it, this is because we're not taking in consideration the order. So there are three ways of doing it. So you have A, B, A, C, and BC. So three letters can have three different orders, and we don't have repetition. To do this, there's a simple program that you can actually write. Okay, so use the combination function to compute the number of combinations of n items taken r at a time. So we have our function factorial, and we have our function combinations int n and r. So we take two inputs in the combination function, and in the main we declare our n, r, and c, and we actually ask the user to enter a number for us. Okay, and we save it in n, and we ask the user to enter a number of components selected. We store it in r, so how many total numbers that we have and how many selected that we have. If we have r less than n, that means that we can do a selection. We say c is equal to combination n and r. When we say combination n and r, this is a function call. We're going to go to the combination n and r. So the combination, this is the factorial, this is the combination, int combination, int n and int r. So n and r, we're going to pass the n and r over here to n and r over here. So by chance this time we have the same names over here and here. Okay, so n is going to be passed to n and r is going to be passed to r. Then you calculate factorial of n, divide by and then you have the brackets. Notice the order of precedence. Factorial of r multiplied by factorial of n minus r. So you calculate the n minus r, calculate you call the function factorial. Is going to go calculate all of this, come back and put the number over here. Factorial of r is going to go over here, calculate the number and put it over here. Then you're going to multiply these numbers, so you finish the parentheses. Then you have to call factorial of n, so you go to the function and you do factorial of n and you come back, and then you do the division of the two numbers to get the factorial of all. Okay, so in the combination function I have called the factorial function 3 times. The first time I called it for factorial of r, this is the first time, this is the second time, and this is the third time I'm calling it. Okay, so 1, 2, 3. I'm calling the same function 3 times. So notice the reusability. I don't have to write the function 3 times. I wrote it once and then I call it as many times I like. Okay, so to solve my problem. So I call it over here 3 times to solve my problem. I actually called over here the combination function, which called for me the factorial function 3 times to solve the problem and come back and give me the result. So this is going to return for me the result, and I'm going to store it into C, and then I can actually print the combinations. If the number was greater than the total numbers, then you actually say you cannot select more than the components that you have in total. Okay, so this is an illustration. Then we have logical functions. What are logical functions? Okay, logical functions are functions that return for you either a 0 or 1. So they return an integer value, 0 and 1. 0 indicates it's true, 1 indicates it's true, 0 indicates that it's false. Okay, a function that returns a logical result should be declared as a type int. Okay, so you declare it always as a type int. In the implementation, the function returns 0 for false and any other value for true, as the case with the true and false in C. Example, the following is a logical function that checks if its integer argument is even or odd. Okay, so if you want to check if the integer argument is even or odd, one implementation is actually say int even int num. So you have a function that returns an integer, the name is even, and it takes an input as an integer, and it will store in a value called num. So you take num, and then inside you have a local variable called answer, and you say answer is equal to num modulus 2 equal to 0. So you take the modulus of 2 of num. If this equals to 0, that means it's an integer number. This will return a 1 for you if num was even, or return 0 if the number was false, and then you can return the answer so you know that it is an even or an odd number. Okay, so usually use the function as follows. If even, you add the number of even numbers by 1, otherwise you add the number of odd numbers by 1. So suppose you're writing a program that the user inputs numbers and you're counting how many even and how many odds that you're doing. So you say if even n. Okay, so it'll go over here and over here. It'll take the number, take the modulus 2 and compare it to 0. If it's 0, it's going to put 1 over here and return it. So you add the number, you add 1 to the number of even numbers. If the user entered an odd number, it's going to come over here. This is going to return a false for you. and then you say that the number of odd is not true, so you add 1 to the number of odd numbers, okay, because this will come false. Okay, so this is how you have a logical function. A logical function returns either 0 or 1. Function with multiple arguments, as we saw in the functions draw rectangle, integer length and wide, and combination int n and int r, a function can have multiple arguments. Okay, so it can have multiple input arguments, more than one. We have lots of example. Below is another example of multiple argument. The first argument, it multiplies its first argument by 10, raises the power of its second argument. So function scale 2.5 and 2 returns for you actually 2.5 to the power of 2.5 multiplied 10 to the power of 2. This is what returns, which is equal to 250. So to do that, you have to declare a function that's of return type double, because we want to have a double number to be returned. You don't know, you might be getting a number just like 2.3333, and if you want to do that and you have 2, so you will actually have to return a double number. So that's why we're declaring this as a double. So it returns a double. The number is scale, the name is scale. It takes two input, multiple inputs, 2, double as input 1x, and the second one is an integer stored in n. So you take these two input and you say double scale factor. This is a local variable, so local variable scale factor is pow 10 and n. So you call the function 10 and n. For this pow function, you'll have to include the math.h, and then you return x multiplied by the scale factor that you have over here. So you will return the number to the function that called you. Okay. Argument list correspondence. When using multiple arguments functions, the number of actual arguments used in a function call must be the same as the number of formal parameters listed in the function prototype. Okay. So if I go back, let me go back to the example. What we're basically saying, the number of arguments when you pass over here, these number of arguments should be exactly the same number of arguments in the function header. If they are not the same number of arguments, you have a big problem. Okay, the compiler is going to generate an error for you. The first number is always going to be stored in the first number, the second number in the second number, the third number will go to third, the fourth will go to the fourth, and so on. Okay, so the order of actual arguments used in the function call must correspond to the order of the parameters. Okay, so if you want to pass a double, if you declare that you have to pass a double and then an integer, please make sure that you pass the double number the first and the integer number the second. Okay, don't cross and change. Each actual argument must be of data type that can be assigned to the corresponding formal parameters with no unexpected loss of information. Okay, so here is another example. Testing the function scale. So when you write the function scale that we talked about and you want to test it, you write your main function and you include math.h and stdio.h, and you declare your prototype double. It's returning a double. The name is scale, and it takes a double x and an integer n. Okay, and the main function, you declare your local variables num1, num2, and you get the variable from the user. So you ask the user to enter two numbers for you. You read them in num1, num2, then you call the function. The result of a scale, you print it out and you call the function the printf, the scale num1, num2. You're actually going to go over here, calculate this, and then you scale it out and then return it and print it using the printf, and then you stop your program. And the user is going to say enter a real number. He's going to enter 2.5, enter an integer -2, and the result would then become 0.025. Okay, so because -2 is 10 to the -2, you're actually making the number smaller. Okay, and if you click over here in your slides, you can have a visualization of how the program actually runs. Please do that in your own time, because it's going to tell you that you're coming from here, you're asking the user to input a number, and then when you call the printf, you're going to come over here and you're going to calculate this, and when you finish, you go back over here and stop your program. Okay. The function data area, we actually talked about this, and we talked about the local variables, so I'm going to just skip this. The function data area is always lost when the function terminates. So when you actually finish the function, any data in it is lost. Okay, it is recreated empty when the function is called again. So if you call a function again and again, you delete the old one and you create a new one. You delete the old one, you create a new one. You delete the old one, you create a new one, and that's what happens. and I actually explained the different function areas. When you have a function calls another function, you will have a function area, and then you can pass the values of the function to that value. I already explained that. Testing a function. Okay, when you're testing a function, it is an independent program module. So test functions are functions that you write to test if your function is working correctly or not, and usually these programs are deleted afterwards. Okay, so it's a full program that you write to test if the function. So if you wrote a function for a factorial, you'll write a function that will actually give it different numbers and see if it's calculating the factorial or not. When you make sure that the function is working properly, you're going to go delete that code and use the factorial function in your original program wherever you want to use it. Okay, so a test function is an independent program module. As such, it can be tested separately from the program that uses it. Okay, to run such a test, you should write a short piece of code. So you write a short piece of code called a driver. This is a driver. What it does, it actually goes and extensiates your code. This is what we call it officially, or what you say, it calls your function, and it calls your function and gives it different numbers, so you'd run it different times, and tests whether the output are correct or not. Okay, so it's called the function and displays the value returned. Okay, and if the value returned is the expected value, you say it passed the test. If the value returned are not the expected values, you say we failed the test. As long as you do not change the interface, your function can be reused. Okay, so if you don't change the interface and the body of your function could be reused. Why do we use functions? There are two major reasons. A large problems can be solved easily by breaking it up to several small problems. Okay, so divide and conquer, and giving the responsibility of a set of function to a specific program. So you come to a very large problem. You divide it into sets of instructions, and each instruction you give to a function. And then when you want to solve this problem, you call function 1, function 2, function 3. It will solve the problem for you. Okay? It is easier to write 10 lines function than 120 line function, and two smaller functions will be easier to read. Okay? So small functions are something very desirable in the industry. They can simplify programming tasks because existing functions can be reused. Okay? So you might make a factorial function today in this course, and when you're graduating, suppose you did a program and you wanted a code that actually does a factorial, and you remembered, oh yeah, I took ICS 103, and in ICS 103 I made a factorial function. So you can come to the ICS 103 database that you have, go to the code over there, cut the factorial from there, and paste it in your function, and the function in your code, and then you can actually use it. Okay, so this is reusability, very important. Really useful functions can be bundled into libraries, just like the stdio.h and all the other things. You can create your own library if you like, but that is an advanced topic we're not going to cover right now. Okay, procedural abstraction, a program technique in which a main function consists of a sequence of function calls and each function is implemented separately. Okay, this is what we call a procedural abstraction. What happens is that the main function becomes a storyteller. It tells you, calculate factorial, calculate GCD, calculate this. You're always calling functions in it that does in it, so it's telling you the story of what the program is doing, and it stops. Okay, the actual work is done in the function. So when you say factorial n, the factorial n function is doing the calculation and producing the factorial, giving it back to the main. Then you're calculating, for example, a GCD, then go to the GCD function, calculating GCD, and come back. So the main function is only telling you the story of what's going on. Okay, all of the details of the implementation are hidden. Okay, just like when you use printf and scanf, you don't care what that printf and scanf actually does. You just call the function and it does it for you. Okay, it becomes the same thing. The main function doesn't care what the function is doing. It calls the function should do what it's doing, and then come back and the main continues. Okay, if you're writing that function, then you are considered about that function. If you're not writing that function, you don't care what the function actually, how it does it, but you care what does it do. Okay, the main function becomes more of abstract outlines. Okay, it becomes an outline. Outline of what? Of what the program codes. Okay, when you begin writing your program, just write your own algorithms in your main function. Take each step of the algorithm and write the function to call it. So what do you do to make it an abstract function is you write your algorithm in the main program, and then for each line you call a function to do something for you, and then this will become a storyteller for you. Okay, Focusing on one function at a time is much easier. It's much easier to focus one task at a time instead of focusing on the entire problem. So when you have a large algorithm, you can write the algorithm and then you can actually call a function that does a specific task like a factorial and go concentrate on making a factorial. When you finish up, come back and then do the other part of the program. Okay, so this is basically why we have procedural abstraction. Reuse of function subprograms. Okay, functions can be executed more than once in a program. So for example, the factorial program and the choose on the combination example, we actually call the function multiple times, 3 times to actually do our job. Okay, so you can reduce the overall length of the program and chances of error. Okay, so the more code you write, the more error it has, so you can actually reduce the chances of having an error. Once you have written and tested a function, you can use it in any program. So once you've tested and it's working really fine, then you can actually use it anywhere that you like. Okay, common programming errors is remember to use the hash include processor directives for every standard library. Place prototypes of your own function subprograms in the source file preceding the main. Okay, so write it before the main. The third thing is the acronyms not summarize the requirement for argument list correspondence. Okay, so provide the required number of arguments. This is the not procedure. Require the number of arguments, the order of arguments, and the type. Okay, so the acronyms not summarizes these requirements for argument list correspondence. So the argument list that you pass, use the not, the number of arguments, the order of the argument, and the type of the argument when considering writing your own functions. Okay, include a statement of purpose on each function. So before the function, write a small comment, and in the comment state what the function is basically doing. Also be careful in using the functions that are undefined on some range of values. Okay, so for example, if you're doing a function that divides, please make sure that you handle the case of dividing by 0, okay, so that you don't get into errors. Okay, and with this we come to the end of this lecture. I hope you enjoyed it. It is a tough lecture, so I wish that you will listen to it 2 or 3 times so you grasp the all ideas in it. Thank you for your time. Bye bye.